Hi, I'm Diego Bermudez, the Research and Impact Fellow for the DICE Network. I'm very sorry I cannot be there, but I will go through my presentation, which is called Transitioning to a Circular Data Center Infrastructure, a Systemic Blueprint for Value Retention and Resource Sovereignty in the AR era. So why are we looking at AI and data centers? Well, we've seen a lot of investment in the past couple of years, especially. There's one example from Microsoft, 30 billion investment. And this is because there are some projections that, well, AI would bring a lot of economic growth, as mentioned in this slide. But as well, in terms of infrastructure, we've seen that there's around a 20% annual growth for data centers. So that's a lot of infrastructure, a lot of electronics that actually are happening there. But given that currently the way that this industry works is actually prioritizing service efficiency and uptime, we do have some shortcomings there. Normally, people tend to look at CapEx instead of longer OpEx, long-term OpEx, and there's a misalignment of incentives here. So we can see that that creates a lot of problems from a material intensity as well as energy intensity, but there's a lot of infrastructure strain in general. This, when we look at the actual supply chain in terms of how the system works, of course, we have this take, make, dispose approach that starts from the mining and refining side of things, that it's currently concentrated in some specific countries. And this doesn't allow to have some flexibility in terms of the supply chain. So there's a lot of problems and risks from a supply chain perspective as well, given that there's a refreshment, a replacement cycle. There's around 3 to 5 years now, instead of going from 8 to 10 years. Plus, there's a lot of waste heat. People in this area tend not to look too much into sustainability because they're pressured by other things systemically. And at last, what we get is a lot of e-waste that is currently not being even recovered, not yet being recycled. So there's a big opportunity for us. In terms of what we actually did at the DICE network, we convened several experts, industry experts, and developed this framework, this three levers framework, design for value retention, operate for maximum recovery, and collaborate for systemic change. And I'll go through each of them in a bit. But basically, what we discussed, we had a couple of workshops and a roundtable where we discussed these three areas more in detail. First one is actually looking at things from design, because that's what actually defines the whole life cycle of a product. And we want to mention that we discovered, or well, so something that we already knew about, that it's not only about establishing kind of like a reduction in terms of the materials that we use, but actually how much do we actually need from that digital sufficiency perspective. But then in terms of designing the systems, we need to design them for repairability, upgradability, and material recovery. How to do that is actually looking into something that the industry already does through the Open Compute project. So they have OCP ready servers that actually kind of interface with each other, and they're swappable. So this helps, but this is mostly for a specific type of data center. Sometimes you have this variability that doesn't allow them to actually develop or to be deployed in that way. So we also have to look into design for this assembly as an important part of how we actually put together these different components within the data centers. And this is actually to make these components available and visible as well, which we're currently lacking that side of things. But we want to make them easy to separate, accessible, repairable, and easy to replace in order for them to be able to extract some of the critical minerals that we have there. And this actually helps from a right to repair policy side and ESPR policies that are critical enablers here. We know that GPUs are being developed. They're currently some of them are being developed with this architectures, but they're still a long way there in order to actually address this kind of problem. There are some people already looking at how to design better, but this is a hyperscaler, like large scale data center side. We know like Microsoft and other big tech companies are trying to establish this given the supply chain risks that they have. But at a lower level, lower scale, we have co-locators like KO Data who are actually establishing this kind of infrastructures for to be ready to be modular, standardized. So they know that there are some problems coming and they want to have that flexibility. As well, AWS, that's part of their business and they want to have enough spare parts there in order to actually be able to operate. So that's what they are most really worried about. In terms of the second lever, maximizing reuse and resource recovery, we want to turn this decommissioned assets, or sometimes assets that are lying there around the data centers, into a global, more efficient secondary market. So we need that companies actually prioritize reuse, and we know that this is not something that you can do with kind of like the top level use cases, mostly like inferencing and training maybe for AI models. But you can come up with an ABC grading system that actually allows companies to reuse and refurbish. So this is giving priority to those upstream interventions instead of going all the way to actually destroying or recycling things. One of the things that we discussed and we talked about that there are already some certifications out there like Lisa and Blanco, which are mentioned there. But the problem is trust. So people are not looking to the right kind of like certifications and don't know how this works. There's still a lot of issues in terms of adoption from the social technical side of things. So although there are OEMs like TechBuyer that actually are enabling this kind of secondary market, there's still a lot of problems because we don't have all the parts that connect that secondary market. We have some certifications out there, but there's still some specific things that we need to work on, like scaling, like authentication services, and of course, access and transparency of parts, where digital product passports might play a big part. Another area that we looked at was what people call power usage effectiveness in data centers is how you use your energy more efficiently within the data center. And that's looking into the amount that the data center actually uses over the energy that the actual IT assets or the different IT assets from a data center use. So that's the ratio. Normally it's between 1.1, 1.2. Some older data centers might go closer to 2. But if we want to make them more efficient, given that there's still, because of physical limits, there's a lot of the heat that is dissipated as low-grade heat. We would want to reuse that heat. And in order to do that, we need to kind of retrofit the infrastructure. And we've seen that in other places like Germany, where they have established this 10% energy reuse factor, but they are struggling a little bit from an infrastructure that heat network needs to be ready to actually be deployed. And we'll talk more about how it's not only about data centers as standalone assets, but it's also how the infrastructure around them should be ready in order to this circular approaches to work. We know that there are already some companies looking into hardware as a service, mostly all the OEMs, Lenovo, HP, Dell. They already establish some really good hardware as a service, but the problem is that they don't have the right visibility. Sometimes it's not deployed in the right way. So instead of looking into how to be able to enable this, we need to look at what incentivizes this from a durability, repairability, and residual value perspective. There are, of course, AI applications looking into how to integrate and make computing more efficient. And this is one of the things that has been discussed around how do we actually make models that are more efficient, not only the way that they compute, but also AI models that are more efficient. The last part is talking about distributed compute, and this is mainly a latency issue because we want to have data centers close to the user so they have the right services provided at a good time. And right now, there are some companies that are innovating in terms of providing kind of edge computing, as it's called, closer to the user, even within their homes, as Kita does. In order for this to work, of course, this is a working problem. We need a system of systems. Um, we need everyone to work together and start having this coordination and collaboration approach in order to change the enablers that are around us, the industry. And we need some contractual limitations there that are not yet there for secondary markets, like BATs and things like that. But as well, as I mentioned before, data security and liability concerns. There's lagging regulation and standards. Right now, the systems are evolving, technology systems are evolving quite quick, and regulations and standards actually are lagging. But also that kind of fragmented planning and resource allocation is something that we need to address in order to be looking at the right problems. And this lack of coordination may actually create a tragedy of commons, as we've seen in the news, with communities complaining about data centers being built in their backyard, something that it's called NIMBism, which is not in my backyard. And that's something that we need in order to develop this further. We know that policy has been working on this. ESPR, the Eco Design for Sustainable Products Regulation, is already working on some establishing some standards there, but needs to move forward. We know the EU Efficiency Directive is there as well, and now they're gathering information from data centers, and that's a great approach, but it's going to take some time to actually create that trust in the data. Digital product passports, which actually started in just in the summer to be kind of implemented within the industry, need to scale up, and that will take some time as well. But we need right to repair laws, and that's something that currently how the market works, not a lot of people are actually pushing for them. One of the main things that we've noticed, as our experts actually mentioned, is that procurement is a big part. We need to think about end of life, not only the first part. And what's happening is that currently IT asset disposition companies take the assets and kind of take them away, and then the user actually doesn't know what happens to those equipments. Instead of having a kind of like refurbished approach, just like DEFRA has been showing with their refer by default policy at an end user device level. So it's important also to mention that something that enables this is measurement. And in order to do this, we need to switch that kind of mentality just to what I mentioned was PUE, which is the most commonly used metric. In order to do this, we need to implement KPIs that look at this from a holistic perspective and measure circular business models. There are already standards out there that outline this, but I'm mentioning here some examples of what we need to start looking at, like material recovery rate, the hardware with DPPs in order to have traceability. What kind of revenue streams are we creating? That they come from circular business models? What kind of supply chain resilience we have? Are we recovering our critical raw minerals and materials from our supply chain? But as well, the main problem that we started talking about, it's e-waste. Are we actually doing something? Normally, people just put this landfill, zero landfill go, and it's not something that we should look for. Is actually how much are we recovering within our own industry and even within the UK. So this works as a system, as a reinforcing loop of how it should work in terms of designing, using, and disposing things in order to collaborate and build these new policies and standards that actually create a better infrastructure for data centers instead of something that is actually extracting resources from people or from their communities. And we see this happening as a resource hub. So we need to provide compute with maximum efficiency and sufficiency, provide heat and energy, and for the communities as well. And also the resources. So we have urban mines across all the different buildings that are part of modern communities. This requires a call to action from different stakeholders across the supply chain or value chain in order to actually make this happen. But at the moment, we are positioned to do this. But there still needs a lot of coordination and collaboration for this to happen. And hopefully we'll do this in the UK in a few years' time. But there's still a lot of discussions going on that will be seen in the next few years of how we actually deliver this AI capacity. So thank you so much. I hope you enjoyed my presentation. And if you want to know more about it, we'll circulate the slides, or you can follow us on our social media there. Thank you.